In this video, we're going to talk about rate of change, which is an application of differentiation. A rate of change is how fast something changes, or how much something changes with time. And we're going to consider three examples to have a look at this. First one is S of t, and this is the distance travelled by a runner. Now, if we have S of t as the distance, then if we were to differentiate, we were to think about the change of S with respect to time. That's what this means, how S changes on the top with respect to time. Or we could, of course, write this as S dash of t as well. Then what this means is how the distance is changing with time. Or how distance changes is just the speed. So in this case, ds by dt is how the distance changes, the rate at which the distance changes with time, and that is the speed at a particular point in time. Okay? Notice this is not its average speed, this is the instantaneous speed at a particular time. This might be measured in something like meters per second, or kilometers per hour, something like that. The second example, h of t, models the height of a person riding a Ferris wheel. So this time we're thinking of dh, the change in height with respect to time. Or we might write this as h dash of t. This is saying the change in height with respect to time. How does the height change as time moves? So as time moves, the height is going to increase and decrease, and it's going to do that at a speed. This isn't the speed that the actual person is moving. This is the speed that the person is moving up or down. So it's actually what we would call the rate of ascent. In this case, the rate of ascent. Not the speed at which the person is travelling, but the speed at which they're going up and down. Because actually in this case, the person is travelling both up and down and to the left and right, because the Ferris wheel is circular. But again, this might be measured in meters per second or kilometers per hour, same units here. The third one, CT, models the capacity of a person's lungs, which changes when the person breathes. So when you breathe in, the capacity of your lungs increases. When you breathe out, the capacity decreases. And it just doesn't have just two fixed values, the biggest and the smallest. It increases slowly as you breathe in and decreases slowly as you breathe out. So this time, we're thinking about dc by dt, or c dashed of t. And this time it's the rate of change of lung capacity. That's what this measures. This is measuring the rate of change of lung capacity. It's not such a nice short word of speed here, rate of change of lung capacity. This is a more general example. And this might be measured in maybe litres per second, because it's the change in capacity. So this isn't saying what is the lung capacity at any specific time. It's saying at a specific time, how is the capacity changing? Is it increasing? Is it decreasing? How quickly is it increasing? How quickly is it decreasing? So this is one example of an application of differentiation, finding the rate at which something changes. And after all, that is what the gradient of a graph tells us. It tells us the rate at which the graph is increasing or decreasing. Well, here, rather than just being a graph, we're applying to specific scenarios. And it's the rate at which your model is increasing or decreasing, or in general, the rate at which it is changing.